I'm Jeremiah from Summer Brothers Construction, and today's video is a mock-up breakdown. When reviewing a cross-section of a high-performance wall assembly, sometimes it can look really complicated and rather daunting. So I created a full-scale, or nearly full-scale, mock-up of one of my favorite wall assemblies, and this is a double wall. Now, I'm certainly not going to lay any claim to inventing the double wall. This has been around for a really long time, and we've simply adapted a version that works really well for our team, works really well for the climate zone that we build in, and that we've found success with. This wall performs highly and is very buildable. And buildable, I think, is key. When we are trying to promote high-performance assemblies and encourage others to consider improving their buildings, then we need to also look at strategies that make this process as smooth as possible so that the learning curve is flattened as much as we can. Now, instead of just simply pointing out the elements of this wall and highlighting certain performance aspects of it, I'm going to strip the whole thing down, take you right back to foundation stage, and walk you through my assembly process, and we'll talk about the details one by one until we get right back to this stage. Okay, now that our mock-up has been taken apart and we are left with our foundation, let's talk about where we're starting and what the first steps are going to be. This represents a really basic stem wall, frost wall foundation with an at-grade slab. So we've got our 8-inch foundation, and we've created a ledge around the perimeter of our foundation. This ledge, in this case, is going to match the depth of our slab. So we're down 4 inches, and we return in 3, leaving us plenty of bearing on top for our wall eventually. Now, the first thing that we need to do is line the interior of our foundation with the insulation of our choice. In this case, we're going to use 2.5 inches R10 of EPS. That's going to go right from this top of this ledge all the way down to our footing. Now, once this wall has been completely insulated, we're actually ready to do our backfill, our compacted stone, and we typically finish that with about 6 inches or 8 inches of a wash stone, something that doesn't require very much compaction or any, and that allows for our plumbing services to easily be trenched in, and we're not worried about having to run a packer back over that and maybe disrupting that. So for demonstration purposes, let's assume all that's done now. All of our below grade surfaces are roughed in, and this is our wash stone acting as our capillary break. Our next move is to install our insulation over top of all of the stone and completing our sub-slab detail. For this example, we're going to use 4 inches of EPS insulation. And now, as you'll notice, and this is kind of key in terms of simplifying some of the detailing, we've now finished our insulation, including our wall insulation, at the same level as our foundation ledge. And the reason we do that is because when we install our stego over top of our insulation, we can now run it right out to the vertical leg of this notch. And the reason that's important is because it makes a really smooth transition across here and allows us to connect our stego to our foundation wall. This can be connected with a variety of materials. Stego makes various tapes and sealants that can do this job. And sometimes we'll use something like a Siga Ventrum, and we'll essentially just fold that right across our corner, and that is going to grab on to our stego and really make a tenacious bond to the concrete, keeping all of that in place. That can work really well. So what you choose to connect this with is your choice. We like Siga Ventrum for this because it works really well and it's really quick. Now that we've completed our stego install, we've sealed around all of our pipe penetrations, we've got it covering all of our insulation on the interior of our foundation, and we've also made the important connection from our stego to our foundation wall. Now we are moving our air control layer to the foundation wall, and I will explain why that is important shortly. So we're basically ready to pour a slab, except we've got a little bit more insulation to complete, and that is to essentially fill in our ledge with another band of perimeter insulation. In this case, we're using a piece of 1.5 inch EPS and a piece of 2.5 inch EPS. And now, if only pouring a slab was this easy, we are ready to complete that detail. So now that our slab's poured, this is kind of a good illustration of how these layers interact, and it's an easy way for me to explain what they're doing. This insulation here is creating a really good thermal break between our foundation and our slab. We've got a good thermal break between the underside of our slab and the ground below. We've even got a little bit of a thermal break kind of on that corner between the corner of our slab and the corner of our foundation. So really, those are our remaining steps before we're ready to start framing. And sort of the important takeaway from all of this in terms of control layer sequencing is that we've now brought this control layer across here, up through here, and now we've got a really clean spot to carry on the process on top of our foundation wall. Just before we install our mud sill and our framing on top of the foundation, we've got one last step, and that's to apply a sill sealer. This is called sill gasket. It's basically a thin foam material, and its primary function is to serve as a capillary break between our concrete wall and our wood framing. The way we complete this detail is to use a sealant like Sashco's Lexel or Big Stretch, and we'll apply a bead all the way along the sort of the interior side of our foundation wall, and that's actually going to go right on top of that Fentrum tape that we have transitioning our Stego to our foundation. Once the bead of sealant has been installed, we're actually going to just lay the sill gasket into that and then follow it with a subsequent bead of sealant just before our mud sill goes down, and that other bead is actually going to go on top of the sill gasket and closer to the outside edge of our wall. Now we're ready for framing. Okay, so framing is now complete, and aside from a couple of differences between this wall and a standard code-built wall, in this case we're using 2x8 to maximize our insulation value, and we're also framing with advanced framing strategies, meaning our studding is on 24-inch centers. Aside from that, it really is no different than what is typically being built to code out of 2x6. Now, where it does differ though is in the continuity of our WRB, our water resistive barrier, and our air barrier control layers. So I'm going to walk you through how the transitions are made and how we basically work that air barrier from inside to outside and then back in again. Okay, our Stego came up the inside of our foundation and was taped and connected to the foundation. Our poured concrete is part of our air control strategy, and remember, an air barrier does not have to be made from the same material throughout a project, but it does have to be continuous. So by connecting the Stego to this, our foundation is now the main component in our air barrier until we get to the outside, where we have connected our WRB, which is in this case Huber zip system, with Fentrum tape back to the foundation. So now we have regained continuity across here and transitioned our air control layer to the outside of our wall. And it doesn't stop there. That air control layer now is continuous all the way up the outside of our wall until we reach the top of our first plate. And here we've used a band of self-adhered membrane from Proclima called Adhero, and we've essentially have it folded down the outside of the zip by about 1.5 inches. It runs across the top of our plate and comes down at the interior. Once that's installed, we can then install our second plate and continue with our roof framing as we normally would. And now our air barrier has been successfully transitioned back to the inside where we can connect onto our interior membranes. Whenever possible, we prefer to frame all of our structural walls, which is generally the exterior walls when we're using a truss roof system, and maybe one or two interior load-bearing walls, depending on the size of the house. But ideally, we're framing only our exterior walls, installing our roof system, and completely drying in our enclosure so that we're left with a wide open space. We don't have partition walls in the way. We've got really no obstacles to have to try and avoid. And this makes membrane installation really quick and a smooth process so that we can use wider rolls. When we're using products like Intello from Proclima, it comes in 10-foot wide rolls, so we can cover a lot of ground. We can eliminate or reduce quite a bit of tape, and it just makes the process really fast when we're not dealing with partition walls and small spaces to try and work membranes into. So now that we've got our framing complete, our air barrier has been transitioned back to the inside. Our next move is to discuss with our mechanical trades, our electricians, our plumbers, and HVAC contractors, where ideal locations for through roof or wall penetrations need to be. Now that our structural enclosure is complete and we've mapped out all of our partition walls on the interior and walked the site with our trade partners, our mechanical, electrical, and plumbing teams, and identified all of the areas where infrastructure needs to either go out through the roof or out through the wall, our crew can come back in and install pieces of essentially scrap OSB between our studs or between our trusses. And really what that's doing is acting like a piece of rigid tape. It just makes it really easy to drill a hole through here, drill a hole through the sheathing, and slide a piece of conduit through, or have the plumbing stack come down through. And from an air sealing standpoint, we're left with one pipe to seal around with some sealant, caulking, or whatever you're using, as opposed to trying to tape and make a nice tight tape connection around a wire or a hose or something like that. So once all those are in place, we're now ready for our membrane to be installed on our ceiling. And that's going to act as our primary air barrier as it's connecting to the adhero that's coming through our plates, and it's going to run across the ceiling, and that will complete the sixth side of our enclosure. All right, we've now installed Intello, which is a smart vapor retarder, and it is acting as not only our vapor control layer, but our primary air barrier at the ceiling. It runs across our entire ceiling and returns down the wall and overlaps the adhero that we have between our plates and folded down our first plate. In order to make this connection, we're using Contiga HF, which is essentially like a caulking style sealant, and we're going to put a bead all the way across the perimeter on our adhero and then simply just press the Intello into there to make that connection. One more connection to make on the ceiling is where we have any penetrations coming down through our plates that we've installed. And because we have a piece of rigid material that was very easy to drill, and we can add a bead of sealant around to seal that pipe, all we're left with is 4 pieces of flat taping against a rigid material, which makes that a whole lot easier to get right the first time. This is probably a good spot to pause and recap where we are so far from an air control continuity standpoint. We started by detailing our subslab with the Stego membrane, connecting it to our foundation wall, and then connecting our zip sheathing at the exterior to the outside of the foundation wall. That moved our air control layer to the exterior of our wall before bringing it all the way up and bringing it back into the interior with the band of adhero at the top plate. Another detail to also focus on is that we brought our air control membrane inboard at our window openings too, by lining our window buck with leftover pieces of zip sheathing and completely taping that. That allows us to make the interior tape connection or sealant connection of our window really smooth and maintain the continuity of our air barrier across the window. Now that we have our air barrier transitioned back to the inside of our building and we've installed Intello across our ceiling and connected it to the adhero at the outside of the wall, our 6-sided box is now completely air sealed. At this point, we're really ready for a pre-installation blower door. And we've done this several times at this stage. And it's valuable because it offers us a chance to fix any real, low-hanging fruit leaks if there are any. And when we've done a test at this stage with the zip acting as our primary air barrier on the exterior and Intello at the ceiling, we've had great numbers. We've been down in the 0.33, 0.34 range on a couple of projects. So that's an excellent result. And really what that shows is that it doesn't really require sophisticated material selection, but it does require, the execution of details and understanding the sequences and making sure that that continuity is maintained all the way around the box. And now we're ready to move on towards insulation. All right, now that our installation is complete in our structural wall and our air barriers across our ceiling and completely detailed, we can complete this part of the assembly by installing our vapor control layer. We're in Climate Zone 5. We are required to install some form of a vapor retarder. We're going to use Intello, and the reason we like Intello is because it's a vapor variable membrane, meaning that it will restrict the flow of vapor from inside to outside. But should water or moisture find its way into that cavity or be in that cavity, maybe caused by moisture in the material that's used during construction, or maybe construction was done during a really wet period of time, this Intello membrane is going to allow inward drying towards the inside, and of course we'll have some outward drying as well. But versus just a straight poly membrane, where we're basically creating, like a plastic bag effect on the inside and not allowing really any drying to come to the inside, we want to use a smart vapor retarder like Intello so that we can maximize drying potential both inward and outward. Right, our membrane process is now complete. And because we're framing this in a wide open room with no partition walls in place, we're able to install these large areas very quickly and easily. We're using Tescon Vana tape to make all of our connections between our membranes. We're also using Tescon Vana around our OSB panels, and then we can just use a sealant around our conduit. And then we're making the connection between our interior vapor control layer and our primary air barrier with Tescon Vana tape around our window openings. So we're left with a really clean wall, and because we're not using the Intello in this case as a retainer for dense pack insulation, we can get away with very minimal staples. And at the bottom, we're going to just simply seal this base of Intello either to our bottom plate with Contiga HF, or maybe even out onto our poured slab. Because the Intello in this case is not being asked to be our primary air barrier, it really is our primary vapor control layer and our secondary air barrier. So its main function is to help resist the interior vapor drive into that wall. So because it's not being detailed like an air barrier, we're not super concerned with this being connected back to Stego or any of our other materials that we're using as our primary air barrier. Now that our membrane detailing is complete and we really don't have any more complicated details to look after at the interior, we can move forward with our interior framing, and that is about as traditional as it gets. We're going to frame our service cavity on the ceiling next, and we're going to complete our 2x4 wall, the double part of this double wall. And really that's not going to be a whole lot different than framing out a basement where we're building a 2x4 wall against the exterior of our foundation. So interior framing is the next step. Now that our interior framing is complete, I'll walk you through the steps that we've taken and where we're at so far. We have our service cavity at the ceiling. We use 2x3 because it gives us a nice 2.5-inch deep cavity, which is really convenient when installing LED light drivers or even octagon boxes and standard electrical components at the ceiling. And that way we can fit them up through the hole that we drill very easily without worrying about damaging our membranes. So we'll typically install 2x3 on 24-inch centers, obviously running perpendicular to the trusses. Now in this case, because our exterior wall in this example also runs perpendicular to the truss layout, we also install a short piece of 2x3 running back directly on the trusses, and that gives us an attachment point for our 2x4 wall inside. Now when it comes to this inner 2x4 wall, there's only one thing that is unique about it. Otherwise, it is about as entry level of framing as you can get. It's essentially a standard interior wall up against our exterior wall. It's framed on 24-inch centers, and we've staggered the studding so that we have a 12-inch offset from our structural wall to our secondary wall. Basically meaning that in front of all these 2x8s, we now have a R14 thermal break, and behind all these 2x4s, we have an R28 thermal break. So it's effectively thermally broken, with a few exceptions, of course, around window openings. Obviously, the framing is going to line up with the framing on the other side. Not a whole lot that can be done about that, but it works very well. It's very easy to do. It's a simple layout, and it's a very teachable wall to frame. The one difference that we've sort of toyed with on this one, though, is instead of a 2x4 bottom plate, we're using a 2x3 bottom plate. And the reason we're doing that is so that we can install a strip of rigid foam between that 2x3 and our outside wall. So that's an 1.25 inch strip of foam there, basically just fattening up our plate and creating a modest thermal break between our plates. I don't think that would necessarily be required, but depending on what material you have and what you kind of want to do with your wall, we found that to work really well. It's an easy upgrade, and since we're only have to fasten screws through our plate into our other plate, it becomes a real easy install. Okay, hopefully I haven't lost you and you're still with me on this, but we're now to the point where this assembly really shines for us. Because this double wall is split into 2 phases like this, we now have effectively created an interior skeleton to install all of our services. And this means that essentially for the life of this building now, this membrane really does not need to be interrupted in any way, with the exception of a major renovation, or, you know, somebody installs a window somewhere else later. But by and large, that gets to stay there forever and becomes completely protected. And because this cavity now is wide open, our electricians, our plumbers, our mechanical contractors, whoever's working on this doesn't really need to know anything about this assembly. I mean, if they do, that's great. We're always trying to educate and work with our trade partners on this and explain why we're choosing these strategies. But you know, not everyone is totally willing to dive into the nerdness of this like we are. So they can go about their business really exactly the same as they would on most projects, except for the fact that when they're coming in to rough in on our projects, and we are in a cold climate, we're now completely insulated. By this time, we have our attic rough-in is done. Our structural wall is complete. It's fully insulated. All the sleeve penetrations are through. So the main rough-in now is in a completely insulated enclosure, which means in the dead of winter, we can heat the building, and instead of, you know, trying to pull wires with snow flying in above the top of the wall because nothing's closed off up there, this can actually be done in, with bare hands and very comfortable working environment. And when it's comfortable, it's efficient, and people are generally happier about what they're doing. All right, speaking of the electrical side of things, and since most of the services that will get run in an outside wall, an exterior wall, are electrical services, receptacle boxes, switches, maybe some wall sconces, that sort of thing, I'm going to focus in on that for just a moment. You can see that we now do not need to use vapor-tight receptacle boxes. We don't need to try and take poly and create a weird bag around our receptacle box to try and create a vapor and air seal. We don't need to buy anything special. I just happen to have a couple of plastic boxes sitting here, but we could use a very standard metal box. It doesn't matter. We can simply attach the box, the way we normally would. And because our studs are staggered, and they're actually spaced off of that 2x8 wall by about a 1/4 inch, it's very easy to pull wire behind the studs. And in spots like this in between, we could add a staple through there, no big deal. And we can get that wire through to the next box without any trouble. So far, no holes drilled at all. And even heading up, if this was a switch, for example, and we needed to get a wire up to a light in the ceiling, because we have a 2x3 service cavity up here, that means our top plate is not in line with the top plate of our structural wall by a little bit. That means we can then easily pull the wire up behind there and across to, again, a standard octagon box with no weird vapor-tight contraption up there because everything else is in place above it. So from an electrical standpoint, it's very simple, minimal drilling, and a very smooth process overall. Now that our services are installed and inspected and we're ready to finish this up, when we're using bats in particular, and if our wire was installed in a traditional way where it was drilled through the center of the stud, that means we've got a wire, and sometimes quite a few, interrupting the space where we're going to install insulation. And so what that means when we're trying to do a quality installation job, that means we're going to have to score our bat, and then we're going to have, in line with the wire, and then we're going to have to fold it open and try and neatly fit it around the wire. However, because our wiring is actually back against our outer wall, we don't have to do that. We can just simply place our bat into the cavity, and is about as easy to install as it gets. Is that a huge deal? Maybe not. But, if you have enough spots around the house like that, it does take a little bit more time, and this just improves the quality of the install that much more. Now, on a traditionally detailed wall where maybe the vapor and air control membrane is against the surface, the interior of the studs, this is one of the scariest tools on the site. Taking a cutout tool to cut out receptacle boxes or around a window or door opening is a huge risk when you've spent a lot of time taping off your membrane to the frame or sealing around the box. These things can wreck all of that in a few seconds. By having our membrane protected behind this 2x4 wall at our window openings, it is just like an interior wall at that point. These are, completely acceptable and not scary at all. Cutting around a receptacle box, maybe someone's new to one of these and they go a little sideways around the box, nothing to damage in there at that point. How many times have you seen where someone's missed a stud or a framing member with their drywall screws and you've got 6 screws going into nothing except for the membrane? Again, with the membrane protected, there's no risk for any of that to happen. So we're really setting up the subsequent stages of construction to go really smoothly and really minimize risk to these important membranes. Now that this wall is complete and we've sort of walked through our assembly process all the way from the slab to the ceiling, we need to highlight one more aspect that's really key when detailing thick walls, double walls in particular, and that is on the exterior. So we'll take you around to the outside of the wall and we'll talk about that. All right, I'm on the outside of the wall now, and there are some elements I need to highlight that are particularly important when we're talking about fat walls, double walls. And the primary reason for building a double wall like this is to get lots of insulation in there so that we can keep our occupants nice and warm in the winter, nice and cool in the summer, and that's great. However, one of the side effects of adding more insulation to your walls is that we're now slowing the transfer of energy through the wall. That means that we don't have the heat leaking through the wall like we might have in an old building. And so should water ever find its way into that wall cavity, it's going to have a little harder time drying out, whether that's to the outside or to the inside. So we need to make sure that we are maximizing the drying potential of our wall. And the thing we need to start with first is our bulk water management. The zip system works really well for that. It's a fully integrated system. It has, a series of tapes and liquid flashes that work with the WRB material to help provide us with a really robust bulk water management system, in addition to an extremely airtight skin on the outside of our building. When we're detailing all of these, our window openings, we're making sure that we're doing a sill pan. That's a really important element. It's also important that we're adding head flashing above our windows and properly sealing our windows as they're installed. It also means we're adding proper base flash to kick that water out should it ever get behind the siding. That means we're adding a rain screen so that we decouple our siding from the wall, so that it not only helps our siding to last longer by promoting drying from the backside, it also allows our wall to dry into this cavity and have any moisture that does need to dry to the outside, escape freely through our vented channel. So it's not just about adding piles of insulation, it's also about managing bulk water and air control to make this whole assembly perform at the highest level that it can. All right, let's wrap up this mock-up breakdown by highlighting the key components of everything that we've assembled and talked about so far. We've talked about our sub-slab detailing and the way we've created thermal breaks between our foundation and our slab. And we've talked about our sub-slab vapor barrier and how it integrates with our air control strategy. We've talked about our main structural wall and how we've used advanced framing to minimize the amount of wood that's in the wall and maximize the amount of insulation that we can put in the wall. We've talked about adding a really robust WRB system to the outside to manage bulk water and be our primary air control layer. We've talked about using product like Intello, which is a vapor variable membrane, meaning that during the winter months, it's going to restrict the flow of vapor from inside of the home into the wall cavity. And in the summer months, it's going to allow moisture vapor transmission through there towards the interior if that's necessary, so that it can dry to the interior of the building. We've talked about why tapes are important to make these connections and how we have integrated our air barrier strategy across our ceiling and protected all of these membranes with a service cavity, whether that's on the ceiling or acting as our double wall in this case. We've talked about insulating this wall. This is a really robust wall from an insulation standpoint. We've got, in this case, because we're using rock wool, we've got R28 bats in our exterior wall, and we've got R14 bats on the interior wall. That's giving us an R value of about 42 with a really high effective R value. We've talked about how, installing fixtures and wiring and things like that becomes pretty smooth and quite easy to, accommodate a variety of components and make it easy on our trade partners. We've talked about why, a service cavity like this, improves success when it comes to things like drywall and not cutting through our tapes or membranes when we're trying to work with these products. So we've really created what I think is a really robust wall. I think that it's a pretty straightforward wall to build once you sort of have it broken down and you're following sort of step by step. There's really nothing overly complicated about it. And sure, there are going to be some higher costs. We have more insulation in the wall. We're using 2x8 versus 2x6. And there's a reason for that, actually. There's a reason why we've chosen to use 2x8 in this case, because that's actually pushing our vapor control layer inboard a little further. We are in cold climate. We're in like upper climate zone 5, lower climate zone 6, and we do need to have this vapor control layer in place, and we need to have it substantially towards the warm side of the wall. So if we were doing 2x6 wall and another 2x6 wall on the inside, then we would have that control layer really towards the middle, which is really not where we want it. We want to have that inboard a little bit further. So while there may be some additional material costs to put this wall together, the installation process and the learning curve is pretty simple, I think. And I think most people could put this wall together with, a reasonable amount of framing experience and have success with it. So I hope you found this helpful. I had a lot of fun putting this together. Yeah, let me know if you have any questions. I'd be happy to answer those in the comments. And I hope that, this provided with some information that is useful to you, and maybe this works on one of your projects.